Thanks, Jim. So I'm the academic lead for the Science and Technologies Facilities Council Air Quality Network, the SAQN. And I'm hopefully just going to give you a bit of an overview of what that is, what we're looking to do, and actually a bit of a call to ask you to get involved and to ask you how we can make it easier for you to get involved. So next slide, please. So in terms of what is the SAQN, it was developed in response to something called the 21st Century Challenge Network Plus call. So it was centered around 21st century challenges, air quality being one of those. And as such, it needed to address user needs. Hence, we felt that what was really important was involving government, industry, and then the other thing that it seeks to do is to involve research communities other than Science and Technologies Facilities Council community. So that's where they want to try and get STFC science and capabilities used by other communities to try and address these 21st century challenges. And what they were seeking to do was to create multidisciplinary communities around each of these issues. And on the right-hand side, there are just some examples of the networks that were funded previously to this one. Next slide, please. So then the overarching aim of the SAQN is to bring together research, industry, and policy to address these air quality challenges. Next slide. I think what's important there is that we're looking to bring together research, industry, and policy because we need industry and policy in order to define what those challenges are. And we need the researchers to be able to help us to develop solutions to those challenges and to really investigate those challenges. And so the sort of underlying aims of that are to create this multidisciplinary community. But the thing that's sort of unique about the STFC network is that its overarching aim is to exploit the untapped potential STFC capabilities. And this is where I'm going to have to give you a bit more information about STFC, but I'll do that in the next couple of slides. So the kinds of things that we're looking to do are engagement with industry and government, initiating lasting collaborations, and increasing the awareness of what STFC can actually do. And some of that is what I'm doing here today. We do this through things like we have a website, which we'll have the address of later. Anybody who's signed up through that website to the network gets newsletters monthly, which detail not just things that we're doing, but actually other interesting things that are happening in the community. Through meetings targeted on specific areas or on questions that we've been asked, collaboration building workshops, funded projects, specific matchmaking where people come to us with issues, and also travel funding. And I'll go into each of these a little bit more later. Next slide, please. So then I guess the question is, for most of you probably, what is STFC? And I think it's different things for different people. So they carry out frontier research, and that's the people in their core STFC centres, but also in universities who are funded by them. And their core areas of science are particle and nuclear physics, space science, and high-performance computing. But actually what they become aware of is that all the capabilities that they've built up through researching those things could be applicable to other areas, hence the use of these networks. They also have these large scientific facilities, and I'll go into what some of those are a bit more in the next slide. They have underpinning technology and computing to enable them to do the high performance computing and to run some of the modelling stuff that they do, and I will go into a bit more of that later. They have something called science and innovation campuses, which they see as places where they can foster collaboration between industry and academia, and so there are opportunities there. There's co-location of some industry with some of the research centres, but there's also other opportunities for industry to get involved with what STFC do. And then finally, they're also a research funder, so they actually put out calls for research and fund specific research projects too. Next slide, please. So then in terms of the facilities that I was just talking about, they have diamond light source, which is like a giant microscope, and they use it to look at materials at the atomic and molecular scales. One of the benefits of the diamond light source is it's very bright, and so it can see really weak signals. And this has been used in some studies around air quality issues. There's the central laser facility, and that includes particle accelerators, It's been used to do things like probing chemical reactions as they happen. One interesting application we heard about was looking at chemical reactions and how they might happen in the fluid in the lungs. They do things studying biochemical and biophysical processes, and also pinpointing individual particles to allow them to be studied. There's also the ICIS neutron and muon source, which is very similar to the diamond light source, except that it's used to look at materials at the atomic scale, and it's better for looking at light atoms. So they're kind of complementary depending on how you want to look at materials. Next slide, please. Then in terms of their scientific computing facilities, they have the Hartree Centre, which enables industry access to their world-class high-performance computing capability, but also to their software development skills. It includes the largest supercomputer in the world, which is dedicated to that software development, and they are specifically focused around industry. There's the Centre for Environmental Data Analysis, which holds large amounts of environmental data, and they coordinate access to those data collections. It's also linked to the next capability, Jasmine, to allow exploration of that data without the need for you to transfer large amounts of data and large data sets. So Jasmine is the UK's data analysis facility for environmental data, and that enables researchers, as I say, to work collaboratively on large data sets, and to do things like hosting models and data in the same place so that you don't have to do huge amounts of data transfer. Next slide, please. So then in terms of their expertise, they have expertise across a whole host of areas, but perhaps the ones relevant to air quality are computational chemistry, computational engineering, particularly computational fluid dynamics modelling, model coupling and how you couple different types of models together, data integration and visualization, machine learning and artificial intelligence technologies for data analysis, software development and engineering, petascale storage, satellite measurements, instrumentation and data. And this is linked to the next thing, which is the development of instrumentation. So they do a lot of instrument development, both for their space science and for their satellite measurements. Looking at novel technologies that can work in harsh environments, things that are compact, lightweight, low power, autonomous, all things that we might think of as being ideal for things we want to do in the air quality field deployment. And so they've got a lot of expertise in this space, and actually that's one of the things that the network has taken advantage of so far. If any of those areas are of specific interest to people listening, then you're welcome to get in touch with us at the SAQN. There'll be details later of how to do that, and we can discuss with you specific interests and match you up with someone from STFC to get more information. Next slide, please. So then in terms of how we achieve each of our aims that we expressed before, in terms of engagement with industry and government, we have industry and government representatives, including Jim, on our steering committee, and they challenge us on what we choose to do and how we choose to do it. We run these kind of matchmaking activities, so where people come to us with a problem or scientists come to us with something they'd like to do, and we matchmake them either with STFC people or with researchers who can help them to solve those issues. And identifying the priorities for our network is also something we like industry and government to do. In terms of initiating lasting collaborations, we want to have collaborations that don't just last for the length of the network, but that actually continue on much longer than that. And so to do that, we have travel funding to allow people to go and visit STFC sites, to work with STFC scientists, to go to meetings where they can talk to other people about the ways that they want to go about addressing air quality challenges. So far, they've been used very little because of COVID, so that's something that we're really going to be pushing over the next couple of years. We have annual meetings, where a large part of that is about trying to get people talking to each other. So although we do have presentations, there is a large part of getting input from the people at the meeting. We've run 2 collaboration building workshops, and they're actually specifically to build things, to build new collaborations, but also to build proposals for projects that we can fund. And that links to the next bit, which is funding, scoping, and proof of concept studies. So we've had all of our scoping study funding already allocated, but what's coming up early next year is proof of concept funding. And there'll be an announcement about that early next year. And then in terms of increasing STFC awareness, meetings and networking, things like this, again, using the travel funds so that people can get to know what's actually of use to them, the newsletters that we send out, and also, of course, our website. So one of our questions to you as an audience is, what would enable you or encourage you to engage with the network? Are there things we should be doing on top of this that you think would be better? We feel that the wider the community we can engage, the more likely we are to find people who can really make use of STFC capabilities in order to drive forward work on air quality challenges and to do novel things. So we're keen to do whatever you think will enable you to engage in the network. Next slide, please. So then I'm just going to quickly run through some of the funded studies to give you a flavour of what we do and a flavour of the kinds of things in STFC that are helping with that. So the first one is called Air Quality Reference Units for Low Resource Regions. And essentially that's about where there are sensor networks in low resource regions, how do you calibrate them? How do you create something that's, if you like, a better quality measurement that can be used to reference those sensor networks too? So there's a piece of work going on around that, and that's using expertise from STFC on spectroscopic modelling and the adaptation of existing measurement techniques and miniaturization. Our second one is the project that actually Dave mentioned in his talk, so using satellite and ground measurements to track ammonia. And the STFC capabilities there were to access and use satellite data, to have the expertise of people who have created that satellite data so that the use of it is optimal, to use artificial intelligence and big data statistics. I think what's nice about this one is this one's completed already, and coming out of that is that it's feeding into how STFC are developing their algorithms to be able to do ammonia measurements from space. And it's also showing some interesting things about trends in ammonia that were unexpected that's been reported to DEFRA. So we're actually seeing that even from this very small project, there have been outputs that are interesting, and hopefully it's going to be an ongoing collaboration to do more. The third one's machine learning to speed up real-time air quality prediction. So this is looking at replacing parts of a process-based model with machine learning in order to speed it up but not compromise its ability to predict. And that's using Jasmine, the Hartree Centre, access to different sources of data, and also model setup on different systems. Next slide, please. Then the next project is around the sort of real hot topic at the moment of indoor air quality, and using a unique facility at the University of Chester to look at sources, behaviour and potential mitigation. I think what's interesting here is that we've got a real collaboration between people from different disciplines to look at different ways of looking at this problem. One of the interesting bits from STFC is the computational fluid dynamics modelling that they're doing around this, and how they're planning to use that alongside the high performance computing in order to get something interesting out of this study. And then the second one on here is again around sensors. Again, looking at the expertise of STFC around this miniaturization and lightweight technologies. But in this case, they were looking at how you might put sensors onto an unmanned aerial vehicle, ultimately to look at measurements of volcanic emissions. But in this case, thinking about how do we make measurements of things like particulate matter on a moving vehicle when actually you're relying on things like airflow through the sensor and things like that to inform what you're actually measuring. So how do you come out with something that actually means anything that can be interpreted from this kind of measurement? And they're using CAD modelling and prototyping from STFC, the access to and expertise with using unmanned aerial vehicles, and again, the computational fluid dynamics modelling. Next slide, please. So then we have a couple of projects that are in some ways similar. So one which is about nanoparticles at the blood-brain barrier. In this case, it's looking at how particles are communicated from the lung to the brain, which is thought to be a key driver of some health impacts. And specifically, this one is hoping to look at if and how particles can travel across the blood-brain barrier, which is still a big question in that field. And they're hoping to use focused ion beam scanning electron microscopy and neutron spectroscopy to really look at what those particles are doing at that interface. And then the second one is about biomass burning aerosol and the impact on climate and health. And in this case, they're using high resolution spectrometry and spectroscopy, and also the physiochemical characteristics, an experiment on those characteristics to look at how the chemical composition and the physical structure of the burning aerosol affects their role in climate and health impacts. And next slide. Then we have one on persistent organic pollutants. So they're very small in the proportion of particle mass they make up, but we know that many of them are highly toxic. So there's a real question around what role they play in driving health impacts. And this project is hoping to take some first steps to looking at that by looking at the reactivity between the gas and the particle phase, which is something that we don't know very much about. So they're going to again be using neutron spectroscopy, model simulations, and laser aerosol analysis from STFC to look, and they're probing lots of different ways to look at these particles to see what might be the best way to investigate health impacts of these kind of compounds. And then almost the final one, a project looking at fluxes and source apportionment using sensor technology. So this is sort of an extension to what's going on with sensors already. How do we actually use them to start looking at fluxes? And I think the sort of novel things that are coming from STFC there are the development of a novel ammonia sensor, their expertise in miniaturization for making this into a flux, able to do fluxes rather than just concentrations, and then having some field sites where they're going to test the newly developed instrumentation. And actually off the back of that is our last project, which is on the next slide, please. And this is something which perhaps we see as a thing having the most significant commercialization potential of the things we've already looked at, which is using the Delta system, which is quite a well-known, well-used method for doing speciated measurements of reactive gases and aerosols, and it's been widely used particularly by the Centre for Ecology and Hydrology. And what they're using there is the ammonia sensor that was developed in the previous project, and looking to miniaturize and enable remote monitoring of the performance of this system in order to make it more widely applicable, so that they could have larger networks of this system. So it's using STFC's Rutherford Appleton Laboratory Space Sensor Technology, looking at applications in the UK, but also where it could be used internationally. And they're really keen to think about how, in the longer term, this might be able to become a commercial product that could then be used in wider places. Next slide, please. So then really, this is my final slide to say, we would love to see more people getting involved. We'd love to talk to you about what you're doing and how that might relate to STFC. So here are some ways that you can get involved at the moment. So signing up for the newsletter, and on the presentation slide there's a link to the website and the page which will allow you to join the network. We're going to have monthly network meetings that will be advertised through the newsletter, where we'll have lightning pitches of a minute each, and then lots of time for discussion around those lightning pitches to allow people to really have a discussion with the wider community. Attend our annual meeting. So our next one's going to be in March 2022. And details again of that will be sent out in our newsletters. Get in contact with us specifically about matchmaking opportunities if you've already got something that you think we might be able to help with. And from the various different communities, we're really keen to get more information about where people feel there are real air quality challenges and knowledge gaps that we need to be addressing. We've got some information about what we've already collected on the website, but if you feel there's things missing, we'd love to hear from you. And on the right-hand side there, we've just got the email address of my network manager, and she's the one who will deal with all the requests that you send her and really progress that. So next slide, please. It's really just to say thank you for listening, and Yeah, we'd like to hear from you about things you think we could be doing, and any questions you have about the network or what we're doing at the moment.
Thank you, Sarah. You have, I think, shone a light on just how wide and deep all of the work of SAQN is. I know when I attend the steering group meetings, I'm like a kid in a candy store. There are so many interesting things going on in the research community at the moment with regards to air quality in particular. And I find it absolutely exhilarating to get involved in some of these things. Um, the I should also point out in the chat that Fleur, in her usual efficient manner, has already posted the link, so you can click directly on that in the chat if you want to find out more about the network and join. One quick question from me, Sarah, and that is, as someone from the private sector and also in my role as the chair of the Environmental Industries Commission Air Quality Group. I think it would be useful to clarify that SAQN is open for private sector people to engage with the research community. In fact, that's one of the standing sort of reasons for being, isn't it? But could you say a little bit about the mechanism? So let's say someone has a problem with measurement or with development of a technology, and they want to engage with SAQN. Can you explain a little bit about not just how they contact us, but how the mechanism might work? How is it funded, for instance, and where do they go after that first contact?
Yeah, okay. So because it's funded by research councils, obviously it is a bit woolly around how industry can engage. So I think it's often how we've gone about it in the past is either where people have come to the network meetings or where we've had specific contact with people around issues that they've got from an industry perspective. And we can either do that through direct matchmaking, where actually all we're doing as a network is to put an industry contact in touch with a researcher or in touch with an STFC person, and then they've sort of taken it offline to do what they want to do from an industry perspective. But there's also we're really keen to get industry involved, perhaps in some of our proof of concept studies. So while we can't fund industry time, that doesn't mean that if industry have an issue that they would like to solve, that we can't fund researchers to work on that if they can show that it's got real benefit to the wider community. And so I think there's something there where industry could get involved around co-funding of those things, or expressing an interest from the point of view of setting out what a challenge might be, those kinds of things. I think we are reliant on industry, and one of the things that we've been weaker on is finding out from industry what challenges they're facing at the moment. And so where could we be trying to direct researchers and STFC capabilities to address those challenges? We've had quite a lot from policy, but not so much from the industry side. And in that case, it is getting in touch with Fleur or through some of the meetings that we hold.
Yeah, thanks, Sarah. And I guess if I'm correct, and correct me if I'm wrong here, once you've engaged with the network, then the potential for Innovate UK, EPSRC, NERC funding may be possible in order to move these things forward, and assisted by the research community who, in my experience, are expert at how to navigate these funding opportunities through the research councils. Is that a correct assumption?
I mean, I think we only hand out small pots of money within the SAQN. So with all of the things that we're doing, we're looking to enable people to get to a space where we've maybe de-risked something that might have been risky or done something that might be new, so that they can then apply for larger pots of money from elsewhere, and they've got that initial data which will enable them to do that. And yes, hopefully the researchers that they're in touch with will have an awareness of that, but we also try to help with signposting where new funding opportunities are coming up.